Talking to you about Akka Typed today. So hopefully you knew that and are here for the good stuff that we can all look at. So if we hadn't worked together, my name is Alejandro again. Like I mentioned, I've been a fan of the library technologies, formerly called TypeSafe, for about 6 years now. And during that time, I've been doing development, architecture, but also training and mentoring teams on how to adopt and grow with these technologies, specifically with Scala, Akka, and Play, and more recently playing around with Lagon as well, the new framework put together by Library. So I'm a big fan. I've worked with many teams that are adopting these technologies, and I love it. And this is one of the reasons I organized the Scala Up North conference, the first and only Scala conference in Canada. Before that, most of my career was in Java, so I've been with the JVM for quite a while. Anyway, so let's get to the topic of today, what we're interested in, which is talking about within the actor system, and within Akka specifically, what are the interesting things that Akka Typed brings to the table. So we'll start with what the issue is, what the problem is with untyped actors. And if you work with Akka, this will be very easy to spot and very easy to you working with this. And then we'll talk about what are the things that Akka Typed provides, where the project is at now, and what the future of it might look like. So without further ado, let's jump in. So again, if you work with Akka, this is going to be very familiar to you. But we'll start with a little game. So I'm showing you a little bit of coding here, and I'll give you a few seconds to try and spot the bug. So the behavior is very simple. We have an actor system, and when we run this, we don't seem to see any of the print lines that are defined within the actor. So I'll give you a few seconds to see if you can spot where the issue is. Okay, so let's see how many of you got it right. The definition of our application is perfectly fine. We define an actor system, create an actor, and then send a message to that. And we're sending an envelope with some string inside that says hello. Now, that part is perfectly fine. The issue is the message we're sending is an instance of a case class, and we're pattern matching on the companion object of the case class as opposed to instances of that class. This is a rookie mistake that if you've done Scala for a little bit, I guarantee you've done this more than once. Now, the problem, of course, here is that this compiles perfectly fine. This was not our intention, but it compiles. So we don't see any errors when we try to build this application. Now, moreover, when the application runs, we also don't see, if you haven't configured your actor system in a certain way, we also don't see any evidence that anything is wrong. So in this case, what's happening is we're sending a message to the actor, and the actor is not expecting or handling this message. So by default, unhandled messages are fairly quiet, very silent. There's an event posted to the event stream, but most people, when building the first few applications in Akka, may not be aware of this and may not be monitoring the event stream at all. So if you're not monitoring your event stream, are you debugging or setting on turning on the setting for debugging unhandled messages? If you didn't do either of these, there are some teams who choose an alternative, which is have a default case on all your actors that produce some kind of log event that says, oh, there's an unhandled message here. Now, all of these things are not configured by default, so we have to put a little bit of effort into this, which is perfectly fine. But we might forget, we might not do it on all the actors, we might not use this setting in production. So there are many reasons why this might not be ideal. And of course, we're working with Scala, and when you're working with Scala, you get to love taming the type system. So losing this type safety and the context of message passing and message handling is a bit of a shame. So that's exactly what we're looking for. Now, there is a bit of a historic reason as to, not a bit, but a very important few reasons why actors are untyped in the message state process. So changing behavior or using contexts that become might be challenging. So this was one of the reasons why the default implementation of actors are untyped, but also distribution. We're working across a network link, or when crossing actor system boundaries, it might not be obvious how errors might be detected if you're working with separate JVMs. So there are good reasons why, and serialization as well. There are good reasons why the default implementation of actors is untyped. So the Akka team has put together, and this is the third effort now for trying to add some type of type verification to message definition and message handling. Okay, so can we do better? Yes, we can. This is exactly why Akka Typed exists. So the goal here is very simple in principle, and the goal is we want actors to expose message types so that they can be enforced at compile time. We want to make sure that if we're trying to only recognize or handle messages of that envelope, that we don't send something else that is not an instance of that. So we want our little code example before to fail compilation because we are not handling or we're not sending the right type of message. Okay. So having said that, let's start with the most fundamental pieces that Akka Type provides or brings in. The first thing is, well, an actor ref is a basic construct that allows us to send messages to an actor. Akka Type introduces a variant of this. It's an actor ref that has one type parameter that indicates the type of messages we can send to that actor ref. So when we see an actor ref of M like this, we know, and the compiler is able to enforce throughout the use of the library, that we can only send messages of type M. So something else in the compiler will warn us, or will actually produce an error. We have something similar. We have an actor system defined in Akka Type. That is an actor system that has a root actor that can only receive messages of that type. So this is interesting. This is fairly new because an actor system has some special actors on the top of the actor hierarchy, what we call the guardians. There's a root actor, there's a user, and system actors. But now we're introducing the idea that we will create a root actor, we'll provide some kind of root actor that is only able to handle messages of that type. And we'll see, of course, examples on how this works and why this is interesting. So we have typed versions of actor ref, an actor system, and then we'll work quite a bit with behaviors. And behaviors are going to be the basic DSL construct that we will use to define how to react to messages of type M. So instead of writing our actors directly, we'll write behaviors that will be translated into actors. So what are some of these behaviors and how and what do we do with them? Well, behavior defines again how to react to a message. Messages are the things that the actor exposes that he wants to handle. Typically are business meaningful messages, right? This could be add user to a user cache, retrieve list of users, or produce, trigger some kind of text processing, etc. Right? So messages that represent actions on our system. But we also talk about signals being lifecycle events or events that are relevant to the actor system itself. We'll see examples of this very shortly. So when we think about a behavior as defined in Akka Type, we see something that's very, very similar to an actor receive method. So let's look at some of these behaviors that are defined on the Scala DSL object of the Akka Typed library. So the simplest one is called static. Static defines a behavior for an actor that doesn't change its behavior. So it doesn't use what we know as context.become. So static is the simplest possible example, and this is what we'll use for a search for a little code example that I brought for you today. But there are more elaborate behavior constructors. There's something called partial, where you can define the behavior of an actor via a partial function. There's total, very similar, but we define the behavior using a total function. And then, with all those three, static, partial, and total, only allow me to handle messages and not signals. So if I also need to handle signals, I'm going to want to use full or full total. Okay. So we have these 5 different constructors, and we'll see a couple examples on how to use them. So the simplest possible use case I could think of is an actor that simply replies. So the canonical echo actor. I send a message, and it replies with the same thing that I sent it. So you'll see that the structure here of creating our actor system has many similarities to what we're familiar with in Akka, and a couple of things that are a little different. So first I define the 2 classes that represent the messages that I'm going to be sending back and forth. So the message case class represents what I send to the actor. It has a payload, some kind of string in there that I'm going to put in just as an example. But it also has a reply to actor ref, and this is really, really important. Because what we will see is we won't have access to the sender method. In this context, in the Akka typed universe, we don't have access to the sender. So the way to wire replies or forwards is to somehow send actor refs throughout the messages. So this technique is going to be very common with Akka type, sending a reply to address as an actor ref. So now I've defined my 2 types of messages, message and echo. Echo is what the actor is going to send back to me. And now, instead of defining a class for my actor, I'm going to define a behavior like this. I'm using static, which again is the simplest behavior constructor I have. Static has one type parameter, which is crucial. It's the type of messages that I can send to that thing. So this behavior is only going to allow me to send objects of type message. Now, in the block of this constructor, I pass in a function that handles the messages that are passed in. So this variable in here is of type message, and I know that because I parameterize static with that. And now in here is what I would typically see within a receive method of an actor, which is how do you react, what do you do when a message arrives? Well, we have some print line in there, and then we want to respond to the sender. Remember, this is our echo actor. So our echo actor wants to send a message back. Again, we don't have access to the sender method. There's no such thing now. Instead, we're going to grab that reply to actor ref that we put in the message case class. Through that actor ref, I can send back the echo message with the same payload that I received. And again, that reply to is an actor ref that is parameterized. It's an Akka typed actor ref that knows it can only receive messages of type echo. So if in this last line of code here, just before I close my expression, if in this last line I try to send something else that is not an instance of echo, I'll get a compile error. Very simple. So this is great. Now, with my static constructor, I've created a behavior that I'm now storing in that val echo. That val echo is now a behavior that can handle messages of type message, and that will send back instances of the echo class. Now, if I want to run this, of course, I need an actor system, and I have to do something for that. So once I've defined my echo behavior, stored in my val echo, I can create an actor system here. And again, I'm using the Akka typed actor system, which is parameterized on the type of messages that the actor system can handle. And that type of message is the type of messages that the root actor can handle. So in our case, we're just putting that echo as a root actor of this system. And the only actor really, because we're not creating any others, so that we can now send that message to the actor system directly. So if we look at the last line, this is also a little new because we were not used to sending messages directly to an actor system with our regular Akka actor systems. So we can use the ask pattern as well. So we're through the ask pattern, we are sending an instance of message to the actor system, which of course will arrive at the root actor. And that root actor, again, is the one that I defined in my echo val. You might have noticed too that the ask pattern has something interesting in here, creating an instance of the message class and using an underscore for the second parameter. This is so the system can inject an actor ref in there to handle the reply. Now, when I am on a regular actor system, my ask pattern returns a future of any, because I don't know what kind of message is coming back. But here, of course, because we're in Akka typed, that future is now typed. So I don't have to call map to or do any type of pattern matching. I know that when that future resolves, it will contain, if successful, it will contain an instance of the echo class, because this is how I parameterized my system. So on the sending a message using my tell method or my exclamation mark, my ban, I have type safety there. On the ask pattern, I also have type safety because I know what type of messages are coming back. Okay, so this is the simplest usage. And by the way, this code is already published in GitHub. I'll show you a link towards the end, so you can see an actual running version of this. Okay, so static allows me to define a very simple behavior. Static behavior does not change through time, it's always the same. And it doesn't give me access to things like self and the context, for example. Now, I didn't need them in my trivial example, but I'll probably need them in more realistic scenarios. So for that, we can use what are called behavior decorators. So again, part of the DSL. And the two main decorators there are the two most important ones. Are context aware, allows me to access the context, the actor context, so that I can get system independent, all those things that I can get to through the context. And I also have a decorator called self-aware that allows me to access the self, because I might need that actor ref to either send a message to myself or to put that in a message again as a reply to address. So those are my behavior decorators, and I'll show you an example of using one of those in our next code sample. So I mentioned there's a difference between messages and signals as well. So our static behavior builder gave us something that can handle messages, but we're not able to handle signals. And signals are related to lifecycle events on the actor system. So I can leverage these as well. I'll receive a signal when I'm about or before I start this actor. So that's the pre-start message. There's a pre-restart, a post-stop, terminated messages if I am doing context watch. So I'm watching other actors. There's also a terminated message, and there's also failure messages if one of my children fails, so that I can make a decision based on that. So all these signals, I think it's an interesting point that they've unified this with regular message passing. So with Akka Typed, we no longer have methods that we can overload or override with it. So those typical lifecycle hooks that we used to have are not available anymore. Instead, we are left with handling signals. So I think it's interesting, gives us a simpler model for handling these things. So again, if you want to handle signals, you have to go for the more complete or more complex behavior constructors. Okay, so having said all that, let's jump into a slightly more complicated example. So instead of one actor saying echo, now we have two actors talking to each other with a little ping pong game. So the setup is very similar, of course. We have messages ping and pong, with some payload in it as well, and each having a reply to address. Of course, each actor is going to need the actor for the other actor. And we're wiring that not in the constructor of the actor itself, but in the messages that are passed around. Our two behaviors are very simple, except we now need the self in order to send that actor ref in the message that we send to the other actor. So now we're using that self-aware decorator to say, well, I need access to the actor ref that points to me. So this is an example of how we're combining a static behavior constructor with a behavior decorator, self-aware. And this way we have access to the message and we have access to the self as well. If we needed to combine that with access to the context, we can also add the context-aware behavior. So we can nest these things so we have access to whatever we need. So PONG and PONG are very simple. Each actor is simply replying to the reply address that's in the message. Now that we have these two behaviors, then we can wire them in together. So we have those two behaviors stored in our variables in there. So our actor system is set up a little bit different. We also have a root actor, of course. We'll call that the main behavior here. Now here we're leveraging a signal in order to start the ping pong game. So instead of sending a message to the root actor system, we're leveraging the pre-start signaling here. So we're creating a behavior using full, because again, I need one full or full total to handle signals in here. Full is going to give me access to any of the signals. In this case, I'm only interested in the pre-start. So when the main behavior starts, what I'm going to do is create an instance of both of those actors, PONG and PONG, and then start the process by sending one message, sending the PONG message and putting the actor ref for the other actor in there. So this line in here where I'm doing the tell is what's kickstarting the game. And then I'll just go back and forth. Now this last line in here, keep that in mind as we go into changing behaviors. But for now, what we need to know is that this simply says, continue doing what you're doing. Once you receive the pre-start signal, just go on and continue doing what you're doing. So now we have an actor system with our root behavior, that's our main. When the system starts, it sends the pre-start message, and then the ping pong game starts. Okay, so that's our slightly more complicated example. But we haven't yet talked about, well, what if I do want my actors to change behavior? Can I do context become? Yes and no. So the answer is, of course, we have a way to change behaviors, but it's presented a little different in here. So first of all, not all constructors allow us to change behavior. So if you do need this, you need to model an FSM in some way or to keep state using this, using behavior changes. Then you're going to want to use one of these constructors: full, total, or partial. So any of those will. And the main problem with changing behavior is that changing behavior is a runtime quality of the actor, which means that at compile time, we can only guarantee that the actor's main behavior can process all messages that we are declaring it can handle. But if we're flipping between several behaviors, so picture your actor having several receive methods, we cannot guarantee at compile time that every single behavior is handling the right type of messages. So we do have to be very mindful here that if we're changing behaviors, we want to make sure that all those behaviors are exhausted. Okay, so what does that look like? So for that, I'm adding, we'll look at one more example where we're modeling a very simple user cache, an actor that keeps a set of all the users that are logged into the system. And each user is just a string, the user. So now what we see is we have an actor that can process two types of messages: add user with a name, with username, and list users, which says just give me all the users you've registered so far. So an actor that keeps that set. Now, because we have two potential user types, we're creating a seal trait in here, a small ADT that contains those two possible message types. So now, my behavior definition, we're using total in here because we want to define a total function. But instead of, you'll notice that I'm using def in here. So just like our def receive on a regular actor can have parameters, and that parameter is one way in which we can keep state throughout behavior changes. We're using the same trick in here. So we can only create a behavior if we call this method user cache and provide a set of strings. So evidently what's going to happen is we're going to start this actor with an empty set. So it starts with no user register. And then every time we receive an add user message, we'll take that username and add it to our user set. But we're not keeping a heart in here. Instead, we're just saying we're creating a new behavior, which is the same type of function, but we're adding the new username there. So here the key is that when we use this constructor, then we are returning, the last thing we're returning of that pattern matching is the behavior to be used from the next message onward. So this replaces the use of context.become. So, and of course we can pal as many of these as we want. And here in my example, I only have one user cache method, but you could potentially see a need for several of these, right? The switch might be on and off. The actor could be connected or disconnected, right? So we can have a much more elaborate FSM defining here. So I have several of these behavior constructor methods. Now, what about the list users? When this actor receives a list users message, it's because someone is asking for the current state of this actor. So we'll just use the reply to address that we put in that message, send in, assume there's a case class in here that contains a set of strings. And now the list users message does not change the behavior of this actor. So we just return the same to let Akka know we want to continue using the same behavior. There's no need to build a new one that's exactly the same as the current one. We just use same to indicate what we want. So what is the risk here? As I mentioned, there's only so much we can do at compile time. If at runtime you change to a different behavior in here that claims to process, let's say, user cache message, but only handles one of these, add user, and forgets to handle list users, the compiler cannot guarantee that completeness for us. Okay? You might get a warning on exhaustiveness checking. That's the most you can get. But at compile time, we cannot ensure otherwise that you handle all possible messages. So that's on you. You have to make sure that you're handling all you say you're handling. Okay, so that is the core and the most important pieces that Akka Typed is offering. And so, in summary, what we're bringing to the table is a version of actor that is typed on the type of messages that an actor can process. A parameterized version of actor system, and that type parameter is the type of messages that the root actor can handle. So obviously, when creating an actor system, we're providing what is the root behavior. We use the DSL for creating behaviors as opposed to creating our own classes. And again, DSLs are wonderful once you learn them, and if they're intuitive, and I think Akka Typed has done a pretty good job at it. But they obviously pose a bit of a difficulty in discoverability. So understanding what you can do with the DSL. Okay. So that's a learning curve that we'll have to go through if we want to use Akka Typed. Reply addresses is also a new approach. Instead of using the sender, we put actor refs in messages. This is a practice that many people were already following, but it's now with Akka Typed would be mandatory. And of course, the last bit that we just talked about, instead of using context.become, we return new behaviors. and those behaviors are the ones that are going to be used from the next message on. So with all these things, we gain type safety in terms of message passing, type safety in terms of the ask pattern, and we have a lot more guarantees that our system is correct and complete. Now, all that is wonderful, but obviously Akka Typed is a very new project, so there are still some limitations and open questions. Being still experimental means that while it's out there for people to try out, things can change, and things can change in non-trivial ways. So be very careful if you choose to experiment with this. It also means, unfortunately, that documentation is sparse. I applaud the Akka team for all the efforts they make on improving documentation. The Akka Typed section is very limited. So if you want to go beyond those first steps, you really have to be willing to go into the source code and move about and understand what's happening. Which is not particularly horrible. The Akka Typed code is, I think, very well written and more understandable than I was expecting. So it's not, it's something that's definitely doable if you're comfortable with Scala. There are still open questions that are not documented, not yet publicized, which are what will happen with actor distribution, so working across several actor systems. What will happen with routers and clustering in combination with this. So that is, okay, so getting a message here, apparently you've been losing me a little bit. I hope it's only been the last little bit. So we're recording this, hopefully the recording will be complete. Apologize for that. Okay, so it's that's all I have for today. I'm hoping you folks have some questions, and I'm more than willing to tackle those to the best of my ability. I am showing here a couple links. The first one would be the examples that I showed in fully running actor systems there. Obviously, we're showing the slides. I had to. Or I chose to skip some of the boilerplate code. So if you go to my GitHub, you'll find there an Akka Typed project that's public for free to browse around. So this is the point where I open the floor for questions. If you have any comments or questions, anything that you'd like to know more about, feel free to ask it on the chat or using the questions link here on the webinar, the Word webinar. Okay, so I don't see any messages. So I think that's it. Oh, there we go. We have a comment or a question from Michael Nash. Can you use Akka Typed in a project with existing untyped actors? Excellent question. And I should have probably made this part of the original presentation. So yes and no. You can definitely mix or send messages through different actor systems, where one handles typed actors or Akka Typed defined actors, and another has undefined or untyped actors. However, if you create an actor system with the Akka Typed constructors, you can only create typed actors in there. So it's not obvious yet how scalable that will be, especially with, again, the open questions that we have in terms of distribution and clustering. How easy it will be to use Akka Typed within that, or whether the strategy is going to be more keep Akka Typed for the local actor system and use untyped on the boundaries, for example. As far as I know, there doesn't seem to be an answer for that yet. I hope that helps answer the question, Michael. Anyone else? Okay, so I think that's it. We'll wrap it up here. Thank you so much for attending, and hopefully a few of you might be watching this asynchronously later. Thank you for watching and or listening. Again, we're Yoppworks, and keep us around on ping us on Twitter. We'll be announcing more webinars and more events in the near future. Thanks everyone for coming.